So when light in the form of photons hits some sort of photoelectric surface, these are metals, an electron on the surface of that metal absorbs the energy. Some of that energy is used to release the electron from the metal, and the rest becomes the kinetic energy of that electron that is ejected. So this is what we're dealing with here, is that orange light, wavelength 610 nanometers, is directed at some metallic surface with a work function of 1.60 electron volts. Calculate the maximum kinetic energy of the electron. Well, we know the wavelength, 610 nanometers. But again, we need meters to do calculations, so this will be 610 times 10 to the minus 9th meters. We know the work function, 1.60 electron volts. But we can't use electron volts in calculations. We need to convert this into joules. And this can be found in the data table that 1 electron volt is the same as 1.60 times 10 to the minus 19 joules. Doing that, we would get 2.56 times 10 to the minus 19 joules for the work function. That's all the information we've been given. And we have two formulas to calculate the energy of an electron. E equals HF minus W works if we have the frequency. We do not. So looking at the other equation, E equals HC over lambda minus W. We do have lambda, so we will use that one. H and C, Planck's constant and the speed of light. We can look those up. H, 6.63 times 10 to the minus 34. C, 3.00 times 10 to the 8 meters per second. Lambda we just found, it's in the question, 610 times 10 to the minus 9 meters. Subtract the work function, 2.56 times 10 to the minus 19 joules. Working this out, this fraction on the left we can deal with in one stop. We get 3.261 times 10 to the minus 19. Just still subtract the work function of 2.56 times 10 to the minus 19. Subtracting that and going to 2 sig figs because the wavelength was given in 2 sig figs. 7.0 times 10 to the minus 20. And this is the kinetic energy of the photon, sorry, of the electron, so kinetic energy is measured in joules. Looking at B, now I want to know the maximum speed of the electron. And I've told you that the mass of an electron is 9.11 times 10 to the minus 31 kilograms, so that is a good starting point. We're being asked to find maximum speed. Speed is v. The only other piece of information that we have that's useful is the kinetic energy that we just calculated. And based on this, we can go back to one of those equations we looked at when we were dealing with energy in Unit 3, and that's EK equals 1/2 mv squared. We talked about it in terms of macroscopic or large objects, but it works for things that are the size of an electron as well. Substituting in what we know, EK 7.0 times 10 to the minus 20. Mass 9.11 times 10 to the minus 31. And I have a small error. That should not be a multiply right before the 1/2. That should be equals. We can multiply the 1/2 times 9.11 times 10 to the minus 31. We get 4.555 times 10 to the minus 31 v squared. Solving for v, we need to divide both sides by 4.555 times 10 to the minus 31. When we do that, we get 1.537 times 10 to the 11th, equaling v squared. Taking the square root of both sides and going to 2 sig figs as this being the final answer, we get that the v equals 390,000. This is a speed, so it's measured in meters per second. Perfectly fine answer, but for a little more clarity of what this actually is in terms of a speed, instead of 390,000 meters per second, we could call this 390 kilometers per second, just to give an indication of exactly how fast these electrons are moving.